Hello guys, so in this video I'm going to talk about how to take natural log derivatives. So they're different from log-based derivatives, so do not get the two confused because they are two different things. Natural log and logarithm are not the same. The ratio of natural log of a over b is equal to the ratio of log a over log b, but natural log derivatives are different from log-based derivatives. So without further ado, we're going to do this problem. So whenever we differentiate, the first thing we're going to do is, for right now, we're going to ignore the 4. So just ignore the 4 and strictly focus on this part of the function, natural log of 2 of x. So what we're going to do is we recognize this is a natural log derivative that it's asking for. So we're going to apply u and u prime. What is u? U is the function of the logarithm. So u is just basically whatever function is inside the logarithm. So in this case, so what we're going to do is we're going to identify u and u prime. So u is the function inside the logarithm. So in this case, the function is 2 of x. And the next thing you do would be just take the u prime. So taking the derivative of 2 of x, we simply get 2. But wait, we are not done yet. No, one thing I do want you to notice that can be misleading is that we did not take this 4 into account, but we did take this 2 into account. And that's very important because if you have whatever is inside your function, as I said in the instructional for this video, do not remove the constant. Do not remove the constant inside the function. Whatever constant you have in front of your natural log does not apply in this formula. This formula only takes into account what's inside the function, not what is outside. So do not take into account what's in front of the natural log, but whatever is inside the function, whatever constants are inside the function of natural log, do take them into account because they are necessary for problem solving this. So now the next step is that we know that the natural log of u, the derivative of it, is equal to u prime over u. So it's literally just plug in. So all we literally do now is just plug it in. It's that simple. So u prime, what's u prime? U prime is 2 over 2x. But now there's another thing. We have the 4 that we pulled out. What we simply do is we multiply the whole function by 4. So we ignored it during differentiation. During taking the derivative, we ignored the 4 because it's not going to help us solve for the derivative. So I did pull it out, but be sure to multiply back by 4 at the end of this because it's necessary for this problem to be able to get the right answer. Multiply by whatever constant you have in front of natural log after you do all the differentiation. If you try to do it during, you're more likely to mess up and get confused. So we're going to go ahead and simplify this a little bit. We see 2 on the top and the bottom, so we cancel them out. So the natural log of u is simply equal to 4 over x. And that's how you take derivatives of natural logs. So step 1, recognize it's a natural log. Step 2, recognize the function inside of the natural log is your u variable. Identify it and take its derivative to identify u prime. Step 3, literally just plug it and chug it into this formula. If you have any constants, multiply by the constant. But do not take the constants in front of the natural log into account, but do take the constants inside the natural log into account. Big difference. And that's all. Thank you for watching. Hope this example was helpful. So in this example, we are taking natural log derivatives and we have a function a bit different. So this is not Do not ever confuse logarithm with natural log because they're two different things in calculus. There's a whole different formula for the derivative of a natural log of a regular logarithm, and I have a video on how to solve that. But this is natural log, so we strictly just stick to how to solve the derivative with a natural log in it. So this problem's slightly different because the function inside of the natural log has an exponent on it. So we're going to go ahead and go about solving this. So notice the first thing we do is we recognize this is a natural log and that we have to take its derivative using this formula right here. Understanding u is the function inside the logarithm. So function inside logarithm. That is our u. So without further ado, we're going to go ahead and we are going to identify u, and we're going to go ahead and identify u as well as u prime. So u is the function inside the logarithm. So the function inside the logarithm is x cubed plus 7. And then the derivative of this function, u prime, is simply equal to 3x squared plus the derivative of 7, which is just 0. So the derivative of u is just simply put 3x squared. So now we have our derivatives. We have our u and our u prime. Step 3 is we literally just plug in. So we plug into formula. So the derivative of natural log of u is equal to u prime over u. And u prime over u is, what's our u prime? Our u prime is 3x squared. And then what's our u? Our u is x cubed plus 7. And this is our answer. 3x squared divided by x cubed plus 7. Just the key step to this is just understanding the function inside logarithm. Identify it as u. Take its derivative, plug into the formula u prime over u. I think that's pretty straightforward. Any logarithm derivative will be able to be solved using this formula. All right, that's all I have for y'all. Hope this was helpful. Thank you guys. Ciao. Bye.